Hi, yeah, I'm Stefan Swanepoel. I'm currently working in the products division of Pragma. My responsibility is I'm the enterprise asset management product manager. So what my role is really to look at our current software products and to see strategically how we need to position them in the future, what functionality will be necessary to support our asset management services, and then also address the needs of our clients by positioning it correctly for future application. Up to now, there was a lot of decision making that was taking place that people did on gut feel or based on experience, human experience. And as we move into the future, more of this will be done based on data, and the expectation is also certainly to be more quantitative about decision making. So what that requires is sufficient data that adequately describes whatever process or asset that we're looking at, so that we can, based on that, accurately make future decisions. So that, and for that, you need data that, describes if it's an asset or if it's a process or a person's work habits, that adequately describes that, so that if one wants to model that and use it in some prediction, that we've got all the data necessary to actually do so. If one thinks about asset management, the different things that plays a role in asset management is firstly obviously our assets, and in terms of the assets, what's their health, what's their condition, what are they performing like, where are they at the moment, what is their configuration. So all those type of information around the assets obviously important. And then when we look at our people that often performs services on the assets or need to operate them, in terms of people, also where are they at the moment, how are they utilized, and then the same goes for tools and other equipment that goes as utility services as part of the asset management operation. We obviously also need to collect data around that, so that we've got a good holistic picture of what our asset management processes are about, and that we can also look at historic data to see what the trends are in terms of how these assets have been performing in the past, so that we can use it in future decision making. There's a lot of talk about the digital twin of everything pretty much, in terms of assets, our tools, our people. So one of the key things for me is that one needs to have an accurate understanding of what are the assets that you own. So, keeping your asset register very accurate, that accurately reflects in the first instance what things I've got, and then building on that in terms of what is their condition. So in other words, monitoring data, how they're performing, performance type data. We need to know what the assets are, when they were purchased, for instance, what costs have been incurred for the asset. We also need to know what maintenance work has been done on the asset, who worked on the asset, what other information is relevant to that asset in terms of materials and manuals and those type of things. That would all be data that would be important for us to invest in, to obviously manage our assets going forward. In terms of the successful implementation of our data processes around the assets, there's a couple of things. In the first place, there's a lot of data that we will be collecting, so we need to make sure that we've got a good architecture, that actually brings all that data elements together. So we need to think about that. We need to think about how we're going to maintain that data going forward, so that we need good governance processes around the data, so that we can in future also rely on that data. There's not mistrust in whether the data is actually all up to date at that point. We need to look at the people that's necessary to maintain those equipment and the sensors and everything that goes around collecting the data. I think a lot of it's going to rely in future on having sufficient sensors on the assets to describe how they're performing, for instance. And we need to know, which of those sensors are becoming redundant, for instance, and if we so heavily reliant on those sensors, that if one fails, what fallback do we have? That's the one part of it. And then I think the other part is we also, as I said earlier, need to have a full picture of the asset performance. So to just rely on one type of sensor, if one take a pump as an example, you could just measure the vibration levels on the pump, for instance, but we also need to look at the performance of the pump. So we need to know the flow rate that the pump is generating. We might also want to understand the motor current that's driving the pump to understand if it's actually operating efficiently. So one needs to have sufficient data points that describes that asset. So I think that would also be quite important. In terms of technical challenges, if one thinks all the way from, if we take the predictive maintenance as an example, and we start from the point where we actually measure the condition of the asset, so there we would need to think about sensors. What type of sensors do we need? In what what environment they're going to be operating? How will they be powered? Will it be battery operated, or can we actually provide them with DC power? Will it be necessary to maintain those sensors? How will we calibrate them and make sure that they remain accurate? So that would be type of the things that one thinks about on the sensor data. Now, one step up, those sensors might be feeding us with a huge amount of information that we can't necessarily always send up to the cloud for processing. So we also need to look at then, at that point already at the edge, how do we compress the data? How do we perhaps already do some analysis on the data collected by the sensor and just send up aggregated data for the higher end systems to process. And then one actually goes into the point where that data now needs to be transferred to the cloud for processing, and that's where things like security becomes important. How are we going to actually efficiently do this? What technology will we be using to do that data transfer? If we think about some industrial environments, things like the electromagnetic environment in which the data transfer needs to take place might play a role. Might be that there's a lot of electromagnetic fields, etc. So Wi-Fi type communication can't work, or your normal 3G data communication can't work. That you might actually need wired communication still. So that would be that part that we need to think about. And then the data is not going to arrive in the cloud. What do we need to provision there for? Where are we going to store the data? How long will we keep that data? What processing are we going to apply to the data as we receive it in the cloud? So that we can again start to minimize the volume of data that we actually pass on to higher systems for decision making. So I think that would be some of the key things that one needs to think about. In general, in all of those, obviously a lot of technology involved in, so one needs to know that those technology providers that you're using are reputable, that in future you won't have problems with obsolescence. So those are things that one needs to consider. I think the interoperability between all those devices will be important, so that one don't need to deal with various types of protocols that these devices need to communicate with each other. So yeah, there's a lot of things in that whole value chain for the data from the sensor up to the point where you process it. And I think all that, what's very important, one also needs to look at what are we going to do with this data now. So then we get into the point of how do we process the data, how do we visualize it to people for decision making, and then ultimately the decisions we make, it needs to feed back in some way to the asset. And in the asset management world, since we're not looking at controls, the feedback would be in the form of replacing the asset when it's starting to become faulty, or when its condition is not good anymore. So linking that all up to your action management system, if you like, to your asset management system that drives the actions that keeps the assets operating reliably. So one needs to think about that full chain of the data flow back to some action that we take based on the information that we receive. I think those are all things that one needs to look at carefully. It raises a very important point. We're talking a lot about technology and data on the one side, But what one always needs to remember is, technology on its own won't deliver us with the solution. So we need to think about technology in the bigger picture of where does it fit into our processes, and what role does our people fulfill in that whole process of actually getting value out of the data that we're collecting, so that we can use that in better decision making. So which brings up the whole point around people and the skills necessary. I think as more and more data gets collected and the volumes of data becomes so much higher than we had in the past, it's getting to a point where it's simply more than a person can consume it at any one point and make decisions about. So we need to think about ways that we can aggregate that data, or also extract from that data some knowledge that the person doesn't need to look into every bit and pieces of data that they receive. And that's where some of the processing that we can either do on the edge in terms of our edge devices, as they receive the sensor data, already start doing some processing on the data, or if we do it in the cloud, where things like machine learning and cognitive processing of data takes place, so that the data that's sent further downstream is in a more condensed way that just highlights main issues and main themes that people as decision makers need to look at. That doesn't discount the fact that we also need to have people with the necessary data skills. We're now looking at huge volumes of data that somebody needs to plow through. So the skills to actually know which tools to use at what point, what type of analysis I'm going to be applying. Am I going to just look at pure correlations of data, or am I going to do some other pattern recognition on it? So there's a skill set required around quantitative measures and data that one needs to look at. And the whole concept of data science is something that I think in future is going to become more and more important. We're investing so much into collecting data, and the people and the tools we use for that, we also need to match it up with investment in the collection of the data. So I think that on the one side, at the high end, is what's needed in terms of people skills. You will need some people that's got some data science expertise, but then you will also have your more operational decision makers that would just need to look at basic parameters and things that's fed to them. And there we just need to make sure that we again have the right high-level people that can specify those tools and the models in which we display the data, and the way that we visualize the data, that it's in a way that the more operational staff can also utilize that data, so that we don't bombard them with lots of data that overwhelms them and they can actually not make sense out of all of it. So the skill around the IT side of things, and the BI component of presenting data in a way that people can use it. So there I think organizations that sort of skills in that level can play a big role in helping clients to make the most out of the data that they receive. And then obviously if one go downstream, I think other skill sets that's going to become more important in future is where in the past a lot of the maintenance that we would have done would have been mechanical, electrical, those type of maintenance. We're introducing a lot of technology into the process as well now, so we will obviously need to skill up and focus more on people that can actually maintain the technology side of things as well. So we'll need to look at either having, if it's a big organization, that type of skills in-house, or partner with the right people to keep all the way from the sensor data up to when we got the data in the cloud, who and what is going to look at maintaining that information. And then I think at the end closest to the equipment, obviously skills and people that understand what sensor is applicable at what for what type of equipment, in what environment it needs to be used, how it's fitted. So those technical skills still to actually go and install and commission this whole digital data chain that we're putting together, that will also be something that will be quite important. In the past, there's been a lot of talk about the importance of data and collecting data, and it's always remained as a far idea that we will one day get to. But I think what we're seeing more and more these days is that future is now. there's already companies that is investing significantly and actually using significantly the volumes of data that's available to them. And I think, to all of us, the important wake-up call is that, it's something that if we're not going to ready ourselves now for it, in a few years' time, we might just not be relevant, because we won't be able to make those accurate decisions around how we need to, position an organization, or which asset we need to purchase, or, how we run the business. And if we don't have it in place now, it might just be that when we start to do that, we're already so far behind that we simply can't compete with the next door organization that's already started with that. So, I think that's the big message. There's a lot of talk about business digitization, but it's not just talk anymore. There's hugely disruptive things that's happening in terms of how services are provided, how we utilize our assets, how we utilize our people, and we need to get on that boat, otherwise we're going to be left behind.